Hi, welcome to my channel. In this video, you're going to learn about graphing rational functions. So what is rational functions? A rational function is a ratio of two polynomials, which means the numerator is a polynomial and the denominator is also a polynomial. Okay, we're going to find the vertical and horizontal asymptotes. We're going to find also the domain and range of the rational function. So we have here a very simple example. We're going to start with this. F of x is equal to 1 over x. So this is a polynomial. That is also a polynomial. Now, we are going to start with finding the vertical and horizontal asymptotes. To find for the vertical asymptote, simply set the denominator equal to 0. Okay, which means x is equal to 0, so that would be our vertical asymptote. What does it mean? It means that the value of x, which is equal to 0, cannot be part of the graph or cannot be the domain. Okay, so we exclude 0 as the domain here. The graph will not pass x is equal to 0. Okay, so that's what vertical asymptote means. Okay, what about horizontal asymptote? For the horizontal asymptote, you are going to check the degree of the numerator and the denominator and compare it. If the degree of the denominator is higher than the degree of the numerator, then your horizontal asymptote is equal to 0. So y is equal to 0. Okay? Because the degree of x is 1 and the degree of the numerator, which is a constant, there is no variable, that is 0. Okay, so now you can sketch the vertical and horizontal asymptote. So since x is equal to 0, the vertical asymptotes is on the y-axis. Okay? And the horizontal asymptote is on the x-axis. Okay, so now, how are we going to sketch the graph? To sketch the graph, so what we're going to do is, we are going to assign table of values. Okay, so we have x, then we have f of x. Okay, now, how are we going to find for the value of x? Now, for you to find for the value of x, in order for you to see the behavior of the graph, you need to choose for on the left side of the vertical asymptote, you need to choose values that are very, very close to the vertical asymptote. So if this is 0, we can choose 1/4 and 1/2 here. So let's have 1/4 negative and negative 1/2. Then negative 1, negative 2. Okay? So we can choose 3 or 4 values there. Or even just 2. Okay, next. Now, for the positive values of x, since this is the vertical asymptote, we're going to find one closer here on the right side. So let's have 1/2. 1/2, that's positive, then 1, then 2. Okay, so we have 1, 2, 3, 4, 5, 6, 7 values, or you can have 4. That's fine. Okay, now what are we going to do is evaluate. So the function is 1 over x. So we have f of 1/4 negative. Let's start with that. And that is equal to 1 over negative 1/4. So 1. So you are dividing fractions. So get the reciprocal of the denominator. And that is 1 times negative 4, negative 4. So this is negative 4. For f of negative 1/2, 1 over negative 1/2. And get the reciprocal, that is 2 over 1, that is negative. Okay, so that is negative 2. Okay, then we have f of negative 1. So 1 over negative 1, which is equal to negative 1. And then f of negative 2, so 1 over negative 2, and that is equal to negative 1 half. F of 1 half. So 1 over 1 half, that is 1 times 2 over 1, that is 2. Okay? Get that. Okay, so let's have, what else do we have? 1. F of 1, that is 1 over 1, that is equal to 1. Then f of 2, that is equal to 1 over 2, and that is equal to 1 half. So this is 1, and this is 1 half. Okay, so let's erase this one, and then we're going to plot the points and see what the graph looks like. So we're going to use different colors here. Okay, so negative 1/4 is here, and then negative 4 is y. Okay, then negative 1 half, so half siya dito, and then negative 2. Okay, and then negative 1, negative 1, negative 2, and then 1 half. Okay. Okay, for positive 1 half, so positive 1 half is here, and then the value of y is 2. And then 1 and 1. And then 2, 1 half. Okay, so if we're going to connect, the graph will be look like this. It looks like this. Okay. So here, you can see. Okay, and then here. Okay, so now here, as we, sorry about the pen. Okay, so here, you notice, as we increase the value of x here, or I mean, 1 and 2, positive. For negative first here. For negative, what have you noticed? The value get closer, very, very close to the horizontal asymptote here. And also here, close to vertical asymptote. It's gonna be very close, but not to the point that it will reach 0. So it's not gonna reach 0 here. For this one, same thing. 2 and 1 half. So here, it's gonna be like this. Okay? Like that. So that's the graph of this function. Now, we can find the domain now. For the domain, this would be, we're going to focus on the x-axis. So look at this one. Going to negative, the arrowhead, going to negative. So that is from negative infinity. Then 0, doesn't include 0. And then we have union 0, then going to positive infinity. So that's the domain. It means here, it shows that 0 is not included, okay? That's why we use parentheses. Now, for the range, we're going to look at the y-axis. So again, this is negative infinity here, and the arrowhead here going down. So from negative infinity, and then if you're going to look at this going up, again, it will not reach 0. And then we have from 0 going to positive infinity. Okay, so that's the graph of this kind of function, the vertical asymptote and horizontal asymptote. Then we have the domain and range. Okay, now here, In this second example, look at this one. What's the difference is we have here x plus 1. A while ago, 1 over x. Okay? So let us compare what happened to the graph or the behavior of the graph here. So first, we're going to solve for the vertical asymptote, which is simply just set the denominator equal to 0 and solve for x. And then this one will become negative 1. So the vertical asymptote now is equal to negative 1. For the horizontal asymptote, again, since the degree of the denominator is still higher than the numerator, that would be y is equal to 0. Okay? So now, the vertical asymptote is negative 1. X is equal to negative 1. So here. Okay, and then the horizontal is still on the x-axis. Okay, now, so you notice, if we add 1 here plus 1, the vertical asymptote simply shifted 1 unit to the left. So if this is plus 2, it means 2 units to the left. Okay, so now, we are going to assign table of values now. So again, how are we going to choose our value here for the x or values of x? This is the vertical asymptote. We're going to choose the values here on the left side of the vertical asymptote closer to this. So what is closer here? This is negative 1. So we can have negative 1 and 1/2. And then, next is negative 2, negative 3. Okay? Now, for here, on the right side of the vertical asymptote, this is negative 1/2. You can have also negative, let's start with negative 1/4, then negative 1/2. Okay? Negative 1/2, negative 1/4, and then 0 and 1. Okay, now we can evaluate f of negative 1 and 1/2. That is equal to 1 over negative 1 and 1/2 plus 1. Negative 1 and 1/2 plus 1 is simply negative 1/2. And that is 1 times, get the reciprocal, and that is equal to negative 2. F of negative 2, 1 over negative 2 plus 1, that is 1 over negative 1, which is equal to negative 1. Okay? Now, f of negative 3, 1 over negative 3 plus 1, that is equal to 1 over negative 2, or that is negative 1/2. Okay, so let's erase this, and so we have space for... Okay, so let's have f of negative 1/4, and that is 1 over negative 1/4 plus 1, and 1 over negative 1/4 plus 1, that is 3/4. 3/4. So we have 1 times 4 over 3, which is equal to 4 over 3, which is 1 and 1/3. Okay, so we have 1 and 1/3 here. 4 over 3. And then f of negative 1/2, 1 over negative 1/2 plus 1 is equal to 1 over 1/2, which is 1 times, equal to 1, that is equal to 1 times 2 over 1, which is equal to 2. And then f is equal to f of 0, that is 1 over 0 plus 1, which is equal to 1. And then f of 1, that is 1 over 1 plus 1, that is equal to 1/2. Okay, so there. Let's see. Let's erase this one. and we're going to graph. First, this is the vertical asymptote. Okay, so we're going to use other color. Okay, now, so let's start with -1 and 1/2. Then the value of y is -2. So here. And then we have -2 and -1. Then we have -3 and -1/2. Okay, so this is the graph here of this part of the function. Okay, then let's continue. So here on the right side, we have -1/4. -1/4 is here, and that is 1 and 1/3. So 1 and 1/3, so here. And then -1/2, then 2. Then we have 0, 1. And then 1, 1/2. Okay, so the graph will look like this. Looks like this, okay? Okay, like that. So you notice that the vertical asymptote shifted 1 unit to the left. And now we can find the domain. Very easy now. So again, focus on the x-axis, -infinity, and then -1. Okay? -1 is not included. Union, -1, and then going to positive infinity. For the range, again, this is -infinity, then going up, and then 0. 0 is not included, and then union 0 to positive infinity. Okay, that's how you're going to find the domain and range. Actually, if your teacher doesn't really require you to have exact graph, you can roughly estimate. You can just, using this one, you can just simply roughly sketch the graph and you can find the domain. Okay, so now here, that's what we're going to do. We're not going to assign table of values. We're just going to find for the horizontal and vertical asymptote. And then we can find the domain. Okay, so here, in this kind of example, so x minus 1 is equal to 0, so x is equal to 1. And that is the vertical asymptote. So x is equal to 1. So it means that from the first graph, it shifted 1 unit to the right because this is minus 1. And then still, the horizontal asymptote is y is equal to 0 because still the denominator is greater than, the degree of the denominator is greater than the degree of the numerator. Now, in my next video, I'm going to show to you part 2 maybe of this graphing, what happened if the numerator, the degree of the numerator is greater than the degree of the denominator. Okay, so now we can sketch the asymptote. So we have the vertical asymptotes and then the horizontal here. Okay, so now, since we know already the limitation that the graph will not go there, which means that the graph will be like this. Okay, and here, okay. Now, what are we going to do? Is find the domain. The domain will be from negative infinity and then 1, which is 1 is not included, and then 1, then going to positive infinity. For the range, negative infinity, here, going up, but it will not going to be at 0 because y is equal to 0, or the horizontal. and then 0 to positive infinity. So the vertical and horizontal asymptote, asymptote means that the x value, which is equal to 1, is not included in the graph. Okay? And the y is equal to 0, that's not included in the set of values for y, or what we call the range. Okay, so that's how you're going to graph rational function. That's all for this video, and thank you for watching, and I hope you're going to watch the next video about still graphing, but this time we're going to find the wholes of the rational function. Bye!